Most of you have heard of the Big Bang Theory. You know, that famous story of a hot and dense fireball, which eventually exploded and formed the universe as we see it today. In cosmology, however, we don't refer to an explosion, but rather to the expansion of space. The original Big Bang Theory was based on the observation that galaxies were drifting away from each other. It was, however, space that was expanding, and not by stretching, but by the addition of brand new space. Around the 80s, space was expected to be expanding at a high rate while slowing down over time. Today, however, the expansion rate looks similar to this. Scientists introduced inflation as an addition to the Big Bang Theory. But why? Let me tell you a quick story about the evolution of our universe. The dense fireball that we talked about earlier can be considered the very first stage of our universe. It was a sphere of opaque plasma. A plasma is a state so hot that even electrons decouple from protons. All elementary particles were separated in this plasma. When the universe expanded, it cooled down along with it. It caused protons and electrons to combine, forming hydrogen. This phase was called recombination. During recombination, a photon was created in the process. By the fact that most moving electrons were absorbed, our sphere turned transparent, making it possible for these photons to escape. Today, this radiation is actually observed in the form of microwaves. This was due to the energy that was lost when the photons traveled through space. This radiation is called the cosmic microwave background, and while it is often showed like this, it actually looks more like this. The temperature of this radiation is almost exactly the same, everywhere. The problem with the original Big Bang Theory is that space expanded so fast that particles weren't able to communicate with each other. Therefore, they couldn't exchange energy, and therefore they could never reach the same temperature. This does not correspond to our CMB. So how did inflation solve this? If we compare the inflation model with the original model, we would find out that inflation results in a much denser sphere. Inflation solves our problem by reducing the distance between particles, giving them enough time to reach the same temperature before the rapid expansion. Without inflation, the Big Bang Theory would leave many questions unanswered. And even though inflation is still a theory, it sure is a problem solver. Thank you so much for watching.